Now, we want to look at the inverse of a matrix. We are asked to find the inverse of the above matrix, that is the matrix 5, 2, 7, 3. Now, how do we find the inverse of a matrix? Now, the arrangement of elements in this manner, that is a diagonal, and that is called the leading diagonal. That is the leading diagonal, and this one is called the other diagonal. So for us to get the inverse of this matrix, then we will find the product of elements in the leading diagonal, that is 5 times 3. Then we take away the product of elements in the other diagonal, that is 7 times 2. And this one is 15 minus 14, and that is 1. Now this difference is called determinant. So in other words, before we get the inverse of a matrix, we must first get the determinant of that matrix. So determinant is the product of elements in the leading diagonal, take away product of elements in the other diagonal. And that one gives us what is called the determinant. So the determinant of this matrix is 1. So for us to get the inverse now, inverse of that matrix will be 1 over the determinant. Then we alter the position of elements in the leading diagonal. Where there was 5, we write 3, and where there was 3, we write 5. So we change the position of those elements in the leading diagonal, and then we negate elements in the other diagonal. So that is -2, and that is -7. So this one we multiply by 1 over determinant. And since our determinant is 1, therefore this one will be 3, 1 into 3, -2, -7, 5. And that will leave that value as 3, -2, -7, 5. Therefore, this will be the determinant of this matrix. Now, what will happen if we now let's multiply this matrix by its determinant. We have the determinant, which is 3, -2, -7, 5. We are multiplying by 5, 2, 7, 3. What are you going to get? We say that the order of multiplying matrices is row times column, and that is 3 times 5, 3 times 5 plus -2 times 7, and then we have that multiplication will give us 3 times 2 plus -2 times 3. And then we come to this one, we now multiply -7 times 5 plus 5 times 7, and when we multiply by the other column, then we have -7 times 2 plus 5 times 3. And what does that one give us? That is 15 minus 14, and that is 6 minus 6. This is 30 minus 35 plus 35, and that is -14 plus 15. And what does that one gives us? That one gives us 1, 0, 0, 1. And this is identity matrix. Therefore, if a matrix is multiplied by its inverse, then it will give us identity matrix. So when you multiply a matrix by its inverse, it should give you identity matrix. Briefly, what have we done? We had a matrix here that is 5, 7, 2, 3, and we're supposed to get the inverse. So we say the first step is to get the determinant of that matrix. And determinant is the product of elements in the leading diagonal. You subtract product of elements in the other diagonal. That one gave us 1. So we say the inverse of the matrix is 1 over the determinant times the elements of the matrix, but with the elements in the leading diagonal altered and the elements in the other diagonals negated. So we negate elements in the other diagonal and alter elements in the leading diagonal. Then you multiply by 1 over determinant, then you get the inverse of that matrix.